what your favorite scientific law says about you. Newton's first law. You think things should stay at rest, and you use inertia to explain why you don't want to get off the couch. Newton's second law. You think force equals mass times acceleration explains everything, and you've definitely used this in arguments. Newton's third law. You love that every action has an equal and opposite reaction, and you think karma is just physics. Law of universal gravitation. You're fascinated by how everything attracts everything else, and you've definitely calculated your weight on other planets. Conservation of energy. You think energy can't be created or destroyed, and you use this to explain why perpetual motion is impossible. Conservation of momentum. You love collisions, and you've definitely explained why car crashes are worse at higher speeds. Conservation of mass. You think matter can't disappear, and you've used this to explain chemical reactions. First law of thermodynamics. You think the universe is just accounting for energy, and you're probably right. Gay-Lussac's law. You think pressure and temperature go hand in hand, and you've used this to explain exploding cans. Avogadro's law. You love that equal volumes contain equal numbers of molecules, and you think moles are genius. Dalton's law. You think partial pressures add up, and you've definitely calculated gas mixtures. Henry's law. You understand why soda goes flat, and you've explained gas solubility to confused friends. Raoult's law. You think vapor pressure depends on mole fraction, and you love colligative properties. Coulomb's law. You think electric force is just gravity with charges, and you appreciate inverse square laws. Ohm's law. You love that voltage equals current times resistance, and you think electrical circuits are just applied math. Kirchhoff's current law. You appreciate that current in equals current out, and you've definitely used this for circuit analysis. Kirchhoff's voltage law. You think voltage drops around a loop sum to zero, and you love conservation principles. Faraday's law of induction. You think changing magnetic fields create electric fields, and you've explained how generators work. Lenz's law. You love that nature opposes change, and you think negative signs and equations are meaningful. Ampere's law. You think magnetic fields come from currents, and you've definitely used this with Maxwell's equations. Gauss's law. You love flux, and you think electric fields through surfaces reveal charge. Snell's law. You think refraction is beautiful, and you've definitely explained why straws look bent in water. Law of reflection. You appreciate that angle in equals angle out, and you think mirrors are perfectly predictable. Beer-Lambert law. You love absorption, and you've definitely calculated how light decreases through materials. Planck's law. You think black body radiation proves quantum mechanics, and you love that it solved the ultraviolet catastrophe. Stefan Boltzmann law. You appreciate that power goes with temperature to the fourth, and you've calculated stellar luminosities. Wien's displacement law. You think hot things are blue and cool things are red, and you've explained star colors. Hubble's law. You love that the universe is expanding, and you've definitely calculated the age of the universe. Kepler's first law. You think elliptical orbits are more interesting than circular ones. Kepler's second law. You love that planets sweep equal areas in equal times, and you think angular momentum is beautiful. Kepler's third law. You appreciate that orbital period squared equals distance cubed, and you've used this for every planet. Law of definite proportions. You think compounds always have the same ratio, and you love stoichiometry. Law of multiple proportions. You appreciate that elements combine in small whole number ratios. Law of conservation of charge. You think charge can't be created or destroyed, and you've used this in physics problems. Heisenberg's uncertainty principle. You love that position and momentum can't both be known exactly, and you think quantum mechanics is weird. Pauli exclusion principle. You think no two electrons can have identical quantum states, and you've used this to explain the periodic table.